we kind of introduced the idea of a different way of measuring around the outside of a circle, besides using just like circumference, besides using degrees. Okay. So let's again talk about that. All right. And there's kind of like two major ways you talked about measuring on the outside of the circle when you were in geometry. All right, if you remember, way back when, right? You had where are my markers going? You had arc measure, right? Which is like a section of the circle, but that would always be in degrees, right? You'd have like major arcs, minor arcs, those kind of things, semicircles, right? Those are always in terms of degrees. But then you also develop the idea of arc length, which is like, how long that arc would be in inches, or how long that arc would be in, centimeters or something like that, depending, again, on the linear measurements of the circle, I guess, and stuff like that. Okay. Both ideas are kind of related, right? But when you talk about, like, the degree of an arc on a circle, it doesn't matter how big or small the circle is, right? A 90-degree arc on one circle will be the same as a 90-degree arc on another circle. As opposed to, if you say a 3-centimeter arc on one circle, that's going to be a different length. It'll look different on another circle because the circle might be bigger or smaller, right? It might be a bigger or smaller portion of the circle. Okay? So degrees kind of like stay the same regardless of the size of the circle, whereas like centimeters or inches, right, the ways you would normally measure circumference, that changes depending on how big or small the circle is. Okay? Because you're always comparing those measurements back to what an actual centimeter is or what an actual inch is, kind of thing. Well, radians are more like degrees, at least when it comes to measuring angles or measuring circles. Okay, no matter how big or small you draw the circle, the radian measure will be the same across all circles and stuff like that. Okay, so let's take a look here, and again, we'll talk about like introduction to radians. Okay. And so as I said, right, from the warm-up there, we established that for any circle, it will take about 6 1/4, right, a little over 6 radiuses or radii to go around the outside of that circle, okay, regardless of the size. So, in the same sense, right, we also said, well, 360 degrees also goes around the outside of the circle regardless of the size, right, regardless of the size. Big circle, small circle, 360 degrees. And so we can, in a sense, equate these two ideas. Okay? 2 pi, but we're not going to say radiuses or radii. We're going to call them radians now. Okay? Because we're going to use these in the context of measuring angles. Okay? So here's our first kind of equivalence. 360 degrees is the same thing as 2 pi radians. Okay? In a similar way, right, you have like conversions for like, I don't know, feet and yards, for example, right? We could say, in a similar sense, how feet and yards are related, right? 1 foot is, 3 feet are exactly 1 yard, right, kind of thing, okay? They both measure the same distance, but you have different units and stuff like that. So this, again, just 2 different units to measure the same thing, okay? Which means then, right, that we can also come up with other kind of equivalent radian degree measures. For example, if 360 degrees is 2 pi radians, what will 180 degrees be in radians? Pi radians, right. What do you have to do there? What math did you do? Yeah, division, right? Just divide both sides by 2, right? 360 divided by 2 is 180, so 2 pi divided by 2 is pi. We have an equation here, so we can do the same thing to both sides, right? And we can keep going. So, for example, if I said 90 degrees, how many radians would that be? Pi over 2 or 1/2 pi? Yeah, I'm going to say pi over 2. That's the more typical way of saying it, but 1/2 pi is also correct. Okay. I'm also going to stop writing the word radians because typically we don't use that as a label for whatever reason, okay? It's just kind of understood that if you're talking about an angle and you don't see the degree symbol, then you assume that we're talking about a radian measurement then instead, okay? Because there's really only 2 ways to measure an angle, either in degrees or radians, okay? So I'll stop writing that. So then 45 degrees, what would that be? Pi over 4, yeah, half of a half, right? So pi over 4. Oops, and I said 4 and then I wrote 2. Okay. So yeah, very good. What about 20 degrees. What would that be? A little bit trickier, right? You can get it from one of our previous answers, though. What? 18. Not 18. What did you get? What did you use? Did you use the 360 or the 180? 360? Okay. So 360 divided by, oh, I see what you're saying. Remember, it's 2 pi that you would divide by 18. So, pi ninths, pi ninths? Yes, pi ninths. Very good. Pi over 9. Very good. Yep, good thinking there. Alternatively, you could have taken the 180, divided it by 9, right? 180 divided by 9 is 20. Pi divided by 9 is pi ninths. Yep, exactly right. Okay. But then, of course, like, so that's pretty straightforward. But then what about something like, what if we want to convert 21 degrees to radians? Well, I guess, I don't know, that's really a question. It's more of a statement, so never mind. We'll get rid of that little question mark part. Okay. Well, that's a bit harder, right? Because it's like, all right, 20 degrees, we could easily convert, we could easily, simplify 180 or 360 down to 20, right, by division. But when dividing to make it 21, that's kind of weird, right? Harder to do. So we need maybe a different way, a better way. Okay, something that's more generally useful. Okay, so 8 times by pi over 80. So that's one way to do it. Yes. Okay, so we can convert here using, I guess what you would call that is like dimensional analysis. You guys like use that in like your science classes and stuff like that. Maybe in Algebra 1, I think it was taught too. So one way you can do this is take your 21 degrees. Okay, we'll put it over 1, just for like that. And then we'll multiply by a conversion factor here, okay? Now, the conversion factor, well, you want to use a radian degree measure that you already know are equivalent. Okay? So, Idris chose to use the 180 in the pi. But you could use any of these. You could use 360 and 2 pi, or the 90 and pi over 2. I'd say Idris probably chose the best one, though. 180 and pi the best because it's most simple. Okay? And then if you remember for dimensional analysis, we want the degrees to cancel. So in a fraction, if I want to cancel my units here, I need the 180 degrees to be in the denominator. Okay? And then, so what's the equivalent radian measure of 180 degrees? Pi. So we'll put the pi radians in the numerator like that. Okay? So the degrees will cancel, and now will be in terms of radians. So 21 pi over 180. But of course we can simplify that some, can't we? The 21 and the 180, they simplify. Both can divide by 3. So we really have 7 pi over 60. Okay, 7 pi over 60. Okay, that's using dimensional analysis. An alternative, if that's not like your cup of tea, all right, although I would really encourage you, if you plan on, if it's a good idea to really get that dimensional analysis stuff down, especially if you're going to be doing like chemistry, any more chemistry and stuff like that, super helpful. But, your choice. An alternative method would be to use a proportion. So we can make 180 and pi in a proportion with each other. And then we'll do a similar proportion over here with the 21 degrees. Now, since I had 180 degrees in the numerator here, the 21 needs to go in the numerator over here as well. Okay? And I'll put an x in the radian position because I don't know what the equivalent radian position is for or equivalent radian measure is for 21 degrees. So here we'll cross multiply, right? So the x times the 180, the 21 times the pi. So we have 180x equals 21 pi. Divide both sides by 180, and you get the same measure that we did before. Okay, which simplifies, of course, to the 7 pi over 60. Okay. So your choice there. Your choice. Okay. The majority of our radian measures are going to have pi's in them, but not always. All right, not always. So just be on your toes with that. 99% of the problems that we'll see when we talk about radians are going to have a pi in them. But every once in a while, they like to change it up and throw like 2 radians at you. Okay, or something like that. And they mean like the book. Okay, so let's try another one here. One more, and then I'll have you guys try 2 on your own. Let's go the other direction. Let's convert, 5 pi over 6 which is, of course, a radian measure, 2 degrees. Okay. So again, we can use dimensional analysis, or we can use the proportion. All right. I put the 21 over 1 here initially because it wasn't a fraction. It's just helpful to have fractions in dimensional analysis, but the 5 pi over 6 already is a fraction, so we can just leave it as 5 pi over 6. Okay, and this time we'll multiply by, okay, well, since this is in radians, since it's already in radians, I want to cancel the radians out. So the pi radians that I'm going to use will go in the denominator, and then the degree measure that I'm trying to convert to 180 there will go in the numerator. So we have to switch where they go here. Since I'm converting from radians to degrees, I need radians in the denominator now, degrees in the numerator. Okay. Okay, up here, right, we had degrees, so I needed degrees in the denominator so that the new units would cancel. Here, since I'm starting with radians, I need radians in the denominator, so those units will cancel, and I'm left with degrees in the numerator. Okay, what simplifies here? What cancels? Pi. Anything else? Yeah, so they both divide by 6, right? So we're left with 1 there, we're left with 30 here. So 5 times 30, 150 degrees. Okay, and of course you can do the same thing if you want to set up a proportion here as well. You know, you can do like 180 again over pi if you like, and then again, in this case, we'll put x in the numerator over our 5 pi over 6 in the denominator. Okay, and again, you can cross multiply and solve here. Okay, you'll get 150 pi equals pi x, and then divide both sides by pi, you get the 150. Okay, so your choice either way there. Okay, questions on any of that? All right, so let me have you guys try 2 on your own here. Here we go. So convert. Convert 300 degrees into some number of radians. And then number 2, convert some number of, convert 7 pi over 6 into some number of degrees. Okay. figure out what you know. It's just basically at any point, if you're like, I have no idea what's happening, let me know. You don't have to like raise your hands on that, like walk around, but just let me know, signal to test something like that. We can figure that out. So. Oh, sorry. Good job. Nicely done. Yeah, yeah. Yes, at the end of algebra 2, right? Yeah. Similar, but not the same, I would say, because he gave you guys like, how many did he, he gave you way more than 5, right?
10.
Yeah, so we're only doing 5.
And the time went down.
And yeah, we will, yes, so the time, yeah, we will like diminish, like the time will adjust depending on things, yes.
4 minutes to do a test.
Yeah.
A quiz, like a short quiz.
It was 5 questions.
Is it going to be cumulative?
And it was based on.
Is the first one going to start with less things and then by the last one,
No, they'll be more like by topic than anything. I will say like the last 3 are kind of cumulative, they like build, I would say, kind of thing.
That's how I did in Mr. Wilson. I talked to for algebra 3.
Okay. Yeah, like the final 3 will be cumulative. Like the first one is unto itself, the second one is kind of unto itself, and then 3 is like baby step to then 4 and 5 are pretty much the same kind of each. They're the 4 and 5 are pretty much the same kind. So. Yeah. Okay, so number 1. Do we have an answer? Anybody? 5 pi over 3. Nicely done. And then how about 7 pi over 6? How many degrees is that? 210. That's right. Does anyone need to see either one of those done? Feeling pretty good about it? Okay, so that's introduction to radians. So what I want to do now is kind of like change just a little bit or like adjust. So one of the other major places we're going to be working, now that we've kind of introduced this new idea of radians, one of the major areas we're going to be working is in the coordinate plane, okay? So like the x and y axis and stuff like that, and we're going to be doing and talking about angles in the coordinate plane, okay? Specifically though, when we start talking about angles in the coordinate plane, at least our angles, the vertex of our angles are going to be located at the origin. And I think this is a better way to go than what I did in my first block class. So anyway, we'll do it this way. Okay? So angles in the coordinate plane. Okay. So vertex is at the origin. Whoops. I'm invading my other part here. Let's see. Okay, that's work. So vertex is at the origin for these angles we're going to talk about. Okay. Also, the starting side of the angle is on the positive x-axis. Okay, so in other words, vertex is here. We'll always start, our angle, one side of our angle will always start on the positive part of the x-axis. Okay, and then positive will go counterclockwise. And since we designated positive as counterclockwise, that means negative will be clockwise. Okay, so just kind of some designations here for us, okay? When we talk about angles in the coordinate plane, for what we're going to be doing right now, our vertex is going to be at the origin. The starting side will always be on the positive part of the x-axis, and then any positive angles we encounter, we're going to be rotating counterclockwise. Any negative angles we encounter will be rotating clockwise. Okay, and so if we think then the positive x-axis as being where we start, okay, then what angle measure would this be? If this was both my starting and stopping side right here, right, what angle measure could this be? 360 or 0, right, if it goes nowhere. So right, you can think of this both as 0 degrees here, or You could think of it as 360 degrees because you could also think about it going, one full revolution around in 360. Okay? Yeah. So then if this was 0 or 360 here, if I went halfway around, what would we call this angle measure right here? Yeah, 180, half of that, right? Okay. And then half again, how much would this angle be right here? 90 degrees, right? 90 degrees, because it is a right angle from the original there. Okay? So in other words, each quadrant is 90 degrees, right? So 90, then another 90, then another 90. What would this angle be right here? 270, yeah. Okay? And then back to the 360. Okay? Of course, then, now that we've talked about radians, right? Now that we've talked about radians, we could also say 0 radians, or we could say 360 is how many radians again? 2 pi. Okay, so instead of saying 90 degrees here, we could say what radians? How many radians? Yeah, pi over 2. And then 180, that's the same as how many radians? Pi radians. Keep trying to make it better. I feel like it gets worse. Okay, that's not bad. And then 270, how many is 270 degrees? How many radians? 3 pi over 2, right? So if that's pi over 2, plus another pi over 2 is 2 pi over 2, which implies to pi, plus another pi over 2 is 3 pi over 2, plus another pi over 2 is 4 pi over 2. 4 pi over 2, that was just 2 pi. So there's your 2 pi. Okay. Very good. Okay, so we'll develop that a little bit more tomorrow, I think, where we start talking. We're going to introduce those special right triangles, or reintroduce the special right triangles that you learned in geometry, the 30, 60, 90, the 45, 45, 90, and we're going to incorporate those triangles here onto our coordinate plane as well, and create something called the unit circle, which is a circle of radius 1, whose center is at the origin, and incorporate the angles from that on there in all the different quadrants. But we'll hold off on that for right now. Okay, but I do want to briefly touch on one more idea here, which kind of has to do with the idea of how you can have two different angle measures to describe the same angle. Right? So this angle right here is both 0 degrees, but it's also 360 degrees. And in fact, there's other ways we could describe this angle. What's another angle measure that's right here as well? In degrees. Besides 0, besides 360, what else can we say here? What other angle would get us back to the same position? So 0 degrees, 360 degrees, what else? What's that? Okay, so like negative what? Okay, so negative 360 would work there too, right? What else? 720, yeah, in our snowboarding or skateboarding friends here, you guys know all these things, right? 1080, right? 540, well, that's actually 1.5 kind of thing, right? But anyway, you get the idea, right? Okay, so there's actually an infinite number of angles here. How'd you get 720? What is that? It's 2 360. 360 is times 2, right? And of course, we could keep adding 360 degrees, and we get in the same, we get in the same position every single time. So any angle that we would have here really has an infinite number of ways to describe what that angle, what that location is. Okay, this idea is called coterminal angles. This idea is summarized by the phrase or the word coterminal angles. Okay. So again, mathematicians not being super creative, but their vocabulary having packed with meaning and stuff like that. Co-share. Terminal, end, right? But also the same start too, right? So coterminal angles share both the same starting and stopping positions. Okay, so like our 0 or 360 or negative 360 or 720 here, all of these angles share the same starting and stopping position. Okay, so these are angles that share the same starting and stopping positions. Angles that share the same starting and ending positions. Which is kind of weird to use that word terminal, right? Because when you think of a something terminal, right? That means that, that's like, normally you think that's the end, right? But I mean, if you think about it, when you go to an airport, right? When you start your journey, you start in the airport terminal, and then when you return, right, you return to the airport terminal. So a terminal is really like an end and a beginning as well, right? So anyway, so I think it does actually apply here, right? It kind of makes sense. Okay. So for degrees then, how are we getting these additional angles? What did we do? We start with 0, and we can just add or subtract what value? 360. Yeah, exactly right. So for degrees, okay, we're going to add or subtract 360 to get more angles. Okay. Let's say I put in, for example, let's say I put in this angle right here on my coordinate plane, 30 degrees, okay? It's between 0 degrees and 90 degrees, so I know it's going to be in that first quadrant there, something like that. Okay? Yeah, another way I could get to this same position here, instead of just going the short distance of 30 degrees, I could go 360 degrees around, right? So 360 plus 30, so 390, and that would give me the same position right there, right? Something like that. Or alternatively, I could have gone the exact opposite direction here. Like that. Okay? So I'm going to put a comma. So that's 330 degrees. We could also say it's 390 degrees. Okay? What would the green, I don't know if you guys can see that's green or not. What would the green angle measure be there? Negative what? 330, right? Okay, so yeah, if that's 30 degrees, then the exact opposite direction around here would be negative 330. Okay, and that also gets you in the same position, same starting point, same stopping point. And of course, you can come up with more. Keep adding 360, keep subtracting 360 to those angles, and you'll come up with more coterminal angles, an infinite number of them. Okay, so I'll put down here, just as an example, 390 degrees and negative 330 degrees are coterminal to 30 degrees, as an example. Okay? So if for degrees we're adding or subtracting 360, then what are we going to do for radians, you think? Add or subtract what? 2 pi. Exactly right. Okay. And for this one, I'm not going to have us do it on the picture up there. We'll worry about that in a little bit because we're not as familiar with where, radian measures are going to be and stuff like that. Let's just say I've got like 7 pi over 6. Okay? And let's say I wanted to come up with a positive coterminal angle to 7 pi over 6. If I want to come up with a positive coterminal angle to 7 pi over 6, what should I do with that 7 pi over 6? Add 2 pi, right? So add 2 pi. But of course, if I want to add 2 pi to this, right, can I add them as they're currently written? What do we need? Common denominator, right? Well, so our common denominator is going to be 6, right? So let's rewrite this. 7 pi over 6 plus 2 pi is how many sixths? 12 pi over 6, exactly right. Okay? So then, what's that going to be then when we add them up? Yeah, 19 pi over 6 there, okay? So there, that's coterminal to our 7 pi over 6 right there. Okay. So why don't you guys go ahead and come up with a negative coterminal angle. Okay, so take that 7 pi over 6, come up with a negative coterminal angle. So think about what you'd have to do to get a negative one. All right, and go ahead and do that. Oh, that's blurry. There we go. Okay. coterminal angle. Okay, question? Sure. Yeah, because I think part of the difficulty is with radians, it's like a brand new unit measure, so it's like kind of strange. So just like we could add or subtract 360, right? And keep adding or subtracting 360 until we want to stop or whatever. Well, let's do equivalently in radians, right? That's your 2 pi's. So adding a 2 pi is adding like 1 full revolution around. So you're still going to end up in the same position as you were here. Does that make sense?
Yeah, no.
So then, of course, now if I want you to get -1, what should you do now? Subtract 2 pi. Yes. So give it a try. Positive or negative? Okay. Sounds good. Yes. Yeah, that's okay. If you got it there, that's okay. You just mentally, yeah, looks good. Oh, okay, that's one. Okay, there we go. Very good. Anything good yet? Think about it? Okay. Got it? Yeah, good. You already got it up in your head. Oh, it's right there. Good. Good. Yes. What are you looking at? Okay, so remember I was looking for a negative coterminal angle. So you found a coterminal angle. You do -4 pi, you do -2 pi, there's lots of options. So this is -5 pi?
Oh, yeah.
Don't forget your
Yeah.
number 6s, right? You're 6. Yeah, okay, is that negative, Jeff? Nice. Oh, I see it. Okay, I see it. Yep, I got it. So you need a common denominator here, right? This is like 2 pi over 1. So you want it to be in terms of 6s. So by 6 over 6, right? Okay. So minus 2 pi, right, is what I saw on pretty much everybody's paper there, right? Okay. Which we can't do because it's not common denominators, so we'll make this then 12 pi over 6, and so we get then the -5 pi over 6 as our answer, okay? Is this the only negative coterminal angle to 7 pi over 6? Is that the only one? No. How can I get more? What could we do? Yeah, keep subtracting 2 pi, right? You can get an infinite number of those coterminal angles if you wanted to. Or if you want to get more positive ones, keep adding 2 pi each time, okay? That's all you have to do, okay? So, questions on any of that? We're all good? All right, so that's all I've got for you here then as far as like what we need to be able to do for today. And so on Google Classroom, I've got posted some practice for you.